The 1963 paper by Edmund Gettier, entitled "Is Justified True Belief Knowledge?" was a highly influential work in epistemology. It was the first challenge to the conclusion that justified true belief is knowledge that I had ever read when I was an undergraduate, and to my knowledge, he is the first to decisively challenge these criteria since Plato over 2,300 years ago. Needless to say, this paper made waves and ended up being one of the most cited philosophical papers of the 20th century. Gettier starts his paper by outlining three sets of criteria for what could constitute knowledge, but since none of them are remarkably different, I'll only introduce one here. S knows that P, if and only if 1. P is true, 2. S believes that P, and 3. S is justified in believing that P. Now, before we examine his examples of justified true belief, or the JTB, that do not constitute knowledge, it is important to note that since he is writing for a Western analytical philosophy audience, his examples presuppose a basic understanding of logic. In logic, the symbol V is used for or, due to its Latin origins. V is short for the Latin word vel, and the symbol can be called vel in isolation. Logicians use vel because the English or is ambiguous. In English, or can be inclusive or exclusive. The exclusive or means you can have whiskey or you can have beer, but not both. The inclusive or means you can have whiskey or you can have beer, but you can have both if you want. In Latin, there was a separate word for the exclusive or, from the inclusive or, vel, that avoided this ambiguity. So, in logic, when we say vel or, we mean it in the inclusive sense. Now, if you've never studied logic, this next part might be a little confusing. In logic, an argument is a conclusion supported by premises, or at least one premise. Premises and conclusions are statements. A statement is a sentence that can either be true or false, but never both. If a statement is both true and false, then it is a contradiction, and is defined in logic as a statement that is never true or always false. In logic, statements are symbolized using metavariables such as phi's and psi's, or p's and q's, and working down the alphabet as needed. Statements can be either atomic or compound. So, you could symbolize the first statement, you can have beer, as P, and the second statement, you can have whiskey, as Q, and these would each be atomic statements. When these two statements are connected with the logical operator or, they form a disjunction and are then referred to as disjuncts, and they form a compound statement. Logical operators include or, and, not, and conditional if-then relationships between statements or metavariables. They are called operators because they operate on the truth of the statements they are applied to. For example, when two statements like P and Q are connected with an or, the compound statement P or Q is only false when both disjuncts are false. To understand and visualize this relationship, it is helpful to use what is called in logic a truth table. A truth table is a tool that can be used on statements and even arguments to establish the possible truth of the statements or the validity of the arguments. The truth table will show every possible combination of truth and falsity for the statements being analyzed. Here is a truth table that demonstrates how an or operates on its disjuncts. As you can see from the first column, the table recognizes that there are only two possibilities for the statement P. It can be either true or false. In the second column, you can see that there are only two possibilities for Q, but when you're comparing them to another metavariable, in this instance P, there are four possible combinations. If you look at the third column, where you see the compound statement composed of the first two atomic statements using or vel, the rule is revealed that this compound statement is true except in the instance that both disjuncts are false. If either is true, then the compound statement is true. This makes logical sense because the disjunction states that one or the other of the two disjuncts are true. This condition is satisfied when both disjuncts are true, because it is the inclusive or, and when either is true, but not when both are false. I'm sorry if that crash course in the logic of disjunctions was too fast, but all of philosophy requires and presupposes familiarity with logic. Logic is required for every branch of science and philosophy, be those metaphysics, epistemology, or ethics. Whether you continue in philosophy or not, the study of logic and critical thinking are extremely valuable, and further study is highly encouraged. Now, with that groundwork in place, we can proceed to Gettier's first case. Case 1. Suppose that Smith and Jones have applied for a certain job, and suppose that Smith has strong evidence for the following conjunctive proposition. D. Jones is the man who will get the job, and Jones has 10 coins in his pocket. Smith's evidence for D might be that the president of the company assured him that Jones would in the end be selected, and that he, Smith, had counted the coins in Jones's pocket 10 minutes ago. Proposition D entails E. The man who will get the job has 10 coins in his pocket. Let us suppose that Smith sees the entailment from D to E and accepts E on the grounds of D, for which he has strong evidence. In this case, Smith is clearly justified in believing that E is true. But imagine further that, unknown to Smith, he himself, not Jones, will get the job. And also unknown to Smith, he himself has 10 coins in his pocket. Proposition E is then true, though Proposition D, from which Smith inferred E, is false. In our example, then, all of the following are true. 1. E is true. 2. Smith believes that E is true. And 3. Smith is justified in believing that E is true. But it is equally clear that Smith does not know that E is true. For E is true in virtue of the number of coins in Smith's pocket, while Smith does not know how many coins are in Smith's pocket, and bases his belief in E on account of the coins in Jones' pocket, whom he falsely believes to be the man who will get the job. Case 2 is where our knowledge of disjunctive logic becomes operative. In case 2, Gettier would have us consider that Smith has strong evidence for the following proposition. F. Jones owns a Ford. Smith's evidence might be that Jones has at all times in the past within Smith's memory owned a car, and always a Ford, and that Jones has just offered Smith a ride while driving a Ford. Let us imagine now that Smith has another friend, Brown, whose whereabouts he is totally ignorant. Smith selects 3 places quite at random and constructs the following 3 propositions. G. Either Jones owns a Ford or Brown is in Boston. H. Jones owns a Ford or Brown is in Barcelona. I. Either Jones owns a Ford or Brown is in Brest-Litovsk. Each of these propositions is entailed by F. Imagine that Smith realizes the entailment of each of these propositions he has constructed by F, and proceeds to accept G, H, and I on the basis of F. Smith has correctly inferred G, H, and I from the proposition for which he has strong evidence. Smith is therefore completely justified in believing each of these 3 propositions. Smith, of course, has no idea where Brown is. But imagine now that 2 further conditions hold. First, Jones does not own a Ford, but is at present driving a rented car. And secondly, by the sheerest coincidence, and entirely unknown to Smith, the place mentioned in proposition H happens to really be the place where Brown is. If these two conditions hold, then Smith does not know that H is true, even though 1. H is true, 2. Smith does believe that H is true, and 3. Smith is justified in believing that H is true. Therefore, justified true belief does not sufficiently constitute knowledge. Now, let's unpack that. In the second example, Smith supposes that Jones owns a Ford, and Smith is completely justified in believing that Jones owns a Ford. But let's turn our attention to another one of Smith's friends, Brown. Brown has not been seen for a number of days, so Smith starts wondering where he is, and notices on sheer whimsy that either Jones owns a Ford or Brown is in Barcelona. Smith is justified in believing that Jones owns a Ford, but he is wrong about this. However, since his belief is a disjunction, it is nevertheless true. To illustrate this, let P represent Jones owns a Ford, and Q represent Brown is in Barcelona. It happens to be the case that Brown is, in fact, in Barcelona. If we revisit the truth table for disjunctions, we will see that even though P is false, the disjunction of P or Q remains true, since disjunctions are always true so long as one of the disjuncts are true. Therefore, Smith has a justified true belief that is not knowledge.